I guess I'm just trying to understand the question. We use the function times the delta to find the inverse, and then we use that to find the area. Not inverse,
the antiderivative.
The antiderivative, and then we use that to find the area.
This is the area. This is the area. The way we calculate the area is this, by the fundamental theorem of calculus. Fundamental theorem of calculus has two parts. I will talk about the first part, hopefully today, but the second part is very important right now. So in order to calculate such an integral, which in turn represents the area under the graph of f of x between a and b, you have to find the antiderivative of this function and evaluate it from a to b. Plug in b and subtract when you plug in a to get this number, because this is a number. The way we calculate this is we have to find the antiderivative of the function and evaluate it at b and a and subtract. Is that okay?
Yeah.
Okay. Now we understand how to calculate, how to determine the limits of the Riemann sum. And now let's go one step forward. Let's talk about properties of the definite integral. There are several properties of the definite integral. So let's take a look at a picture. Here's one property. So let's say this is a function. The way I graphed it between a and b, would you agree that f of x is a positive number? Between a and b?
Yes.
Okay. So would you agree that the area from a to b from f of x dx will also be greater than 0?
Yes.
Perfect. So this is it, the area. So if the function is positive, its area will be positive. That's one property. Here's the next property. Common sense. The integral from a to a from f of x dx. What do you think this equals to?
Single point.
We're talking about area. You're close. Say it again.
Is it 1 or 0?
Of course. Of course. There is no area. If there is no interval, there is no area. Because the base is 0. A minus a is 0 times the height. So base is 0, height is whatever you wanted it to be, it's still 0. Perfect. The integral from a to b from f of x dx is the same with the opposite of the integral from b to a from f of x dx. So this is property 1, property 2, property 3.
Could you move up so I could see property 1 again?
Yes. Yes.
Thank you.
So if the function is positive, then the area has to be positive.
Okay, thank you. I just was finishing
Sure.
writing the graph.
Yep.
Missed the
Yep.
active property.
Good.
Just need to see that for another second.
Yes?
I need to see that one more time.
Sure.
Didn't finish writing.
Is that okay?
Yes.
Perfect. Here's another. a to b from f of x dx. Of course, dx. There is no integral without dx. Here's the graph for this property, and you'll tell me what I should write. Here's the function. Any suggestions?
Would it be like the area of CB is the area of, or the area of AB equals the area of CB plus AC?
Correct. Perfect. We can split in as many pieces as we want. Here's the next one. The integral from a to b from f of x plus g of x dx. Always remember, all these functions have to be continuous. Functions on a comma b. Otherwise, fundamental theorem of calculus is not applicable. You have to wait till Calc 2 for improper integrals.
I'm sorry, could you go back up, or could you move the paper down again just one more time? Sorry, a little more.
Any questions? Can anyone give us the property here? We have the same property for differentiation. We have the same property for limits. Exactly the same. And I can also have the second option here.
Would it be the area or the summation?
The integral from a to b
of fx.
f of x dx. The integral doesn't, yes,
or
minus, right. The integral f a to b from g of x dx. Very good, awesome. Here's another. The integral from a constant. We have the same property for the summation notation, the same for limits, the same for derivatives.
Equals c times the
integral from a to b
dx.
from f of x dx. Awesome. Here's number 7. And now I would like to talk about odd and even functions. And not only odd and even, but on symmetric intervals. On symmetric intervals. Here's what I mean by that. The integral from negative a to positive a, this is a symmetric interval around 0. From negative 5 to positive 5 or negative 2 to positive 2. From f of x dx. And the integral, of course, from negative a to a from f of, yes, correct, dx. For an odd function, let's picture an odd function. Here's an odd function. Here's negative a, here's positive a, here's the area in question. And I want an answer here. And here's the area in question for an even function. But this is very specific on a symmetric interval. we are talking about odd functions on symmetric interval, even functions on symmetric interval. Or in
Would
symmetric.
it be the integral from 0 to a of fx dx times 2?
For this one, 2 times the integral from negative, so basically from 0, right? From 0 to a from f of x dx. Because this area is identical here, so I put 2 in front and determine the area from 0 to a from f of x dx and simply multiply by 2. Awesome. What about here?
Zero.
Very good, of course. This is the same area, but it's negative. This is the same area, but it's positive. So they will definitely go away. The sum will be 0. Awesome. Very good. Any questions on the properties? Because I like to look at some other, the last 2 properties, basically 3 properties. We already talked about the first one, but I need 2 more, and that's it. And then we'll continue with problems. Any questions? Do we all understand this? Okay, so here's property 8. I hope you're going to find it as also common sense. So here is a function f of x, and here is a function g of x. Of course, this is the interval a comma b. Would you agree that f of x is definitely, I don't care outside of the interval, but in the interval a comma b is less than or equal to g of x? Would you agree with that? We agree?
How would it be equal to?
It could be. It doesn't, not in my graph, but it could be. That's what I'm saying. It could be. Would you agree?
Yes.
Okay, then the integral from a to b from f of x dx and the integral from a to b from g of x dx, what would be the relationship between these two?
Less than
Would it
equal to.
also
Of course, obviously. Of course, this area will definitely be smaller than this area under g of x. So if this is the relationship between the 2 functions, that this will be the relationship between the areas under their graphs. Okay, and I promised the last one. Last property. Let's take a look at another scenario. Which number am I on? I'm on 9. So here is another scenario. So let's say we have a constant, lowercase m, another constant, uppercase m, of course a and b. And let's say here is our graph f of x. Would you agree that f of x is between lower m and upper m?
Yes.
On the given interval, of course. Well, then you will have to agree this. The integral from a to b dx, a to b dx, a to b dx. Would you agree with that? It's based on the previous property, basically.
Yeah.
Perfect. So now the middle stays, but let's calculate these two. See what we get. The integral from a to b from f of x dx less than or equal to, less greater than or equal to. Okay, so m goes outside. Which function prime is 1? I have to have something. Like when we had 2 times 1, right? And the sum of this would have been 2, the sum of 1. Same thing here. If I put a constant outside, I have to have a function. The function is 1 then. What function prime is 1?
X.
Perfect. From A to B. Exactly the same idea here. M, X from A to B. We plug in B. We plug in A. Last property, as I promised. Now let's practice this. And then I'd like to continue talking about how we integrate more and more definite integrals, how to find the definite integrals. Okay.
Sorry, I got all of them except I missed 4. Could I see that one more time?
You said 4?
Yeah.
Ready?
Yes, thank you.
Thank you. Perfect. So now let's use these properties. I'm on page 9. Let's use these properties and see what they're asking us to show. Okay, I'm looking at problem 67 on page 397. Use the properties of integrals to verify the inequality, and this is the inequality they want us to verify. Don't try to find the antiderivative of this. So they're asking us to try to show this. They're asking us to prove this. Not calculate. We cannot calculate this. Do not. I'm going to write it, but we cannot. Do not calculate. We're asked to prove. So they're telling us, show me that this is a number somewhere between this one and this one. Okay, so I know we just talked about a property that basically says that an integral is between 2 numbers. So looking back, obviously I have to find and build the function in the middle and 2 numbers, a lower bound and an upper bound if I can. Once I do this, I will integrate and get this. But it's a long way till I get to here. So somehow I have to build this function between 2 numbers. So let's see. Where will be the starting point, do you think? It's okay if you're wrong. Just say what you think so we can discuss it.
2.
Say it again.
2.
Okay, very good point. I'm missing my other prop. Okay. So I don't know what those numbers are. So where will my starting point be? In order, say it again. In order to build a function, what do I normally start with? Before I even get to the function, what am I looking at? Whenever we graph a function, what is the first thing we look at? When we analyze a function, what is the first thing we look at?
Domain.
Yay! So what is the domain here, if you want, so to speak? This is my domain. That's the whole thing. X goes from -1 to 1. That's my starting point. Now, in the middle, my target is to create the function down the road. Let's look at the function. The function has an x squared. So I'm asking myself, in such an inequality, I cannot square this, square this, square this. No. But let's think for a moment. If x is between -1 and 1, where x squared would be? And no, I'm not squaring. Let's think. If I have the interval between -1 and 1, on this interval, how do I graph x squared? No problem. At 1, at 0, and at 1. That's the graph of x squared. If x is between -1 and 1, what is x squared between what and what?
0 and 1.
That's it. Absolutely. If x is between -1 and 1, x squared must be between 0 and 1. Every time I have x between -1 and 1, x squared must be between 0 and 1. Excellent. So I have this little piece, but I don't want that. I want to have 1 plus x squared. What should I do next to get that 1 plus x squared right here in the middle? But it has to be legitimate. I cannot just say throw in a 1 in there. What can I do?
Add 1 to each.
Thank you very much. That is legitimate. Good. Now let's think. All these are positive. Positive, positive, positive. Otherwise, I can't apply the function I want to apply. What is the function I want to apply? Because I'm building this. What function I have to apply to all three sides? So I can build that.
Square
root, square root, square root. Because these are increasing, so then the square root of this will be smaller than the square root of this, which will be smaller than the square root of this. Awesome! That's all I needed. I have the function. I have two numbers. Who cares about those numbers? Nobody cares. But now, because I have what I need, I can do this. Of course, from -1 to 1, from -1 to 1, from -1 to 1. Okay, the middle stays as is. There is no one here who can do anything to it. And I don't even want to. And I don't even care. I need to determine these and check that they are those. The square root of 1 is 1. What function prime is 1?
X.
Good, from -1 to 1. What function prime? The square root of 2 goes in front. What function prime is 1?
X.
From -1 to 1.